All right. Welcome, everybody, to this installment of the Continuous Testing Meetup. First of all, let's thank our sponsors, Source Labs Training and TUI Amusement, to provide the link to this Zoom and to organize all of these meetups. Also, thank you very much to Aurelian for organizing this. And yeah, without further ado, oh no, sorry. First of all, our last meetups are on our website now, so check those out. And now, without further ado, give it up for Josh Grant with Fuzz Testing. Thank you.
All right. All right. Thank you very much, Seb. Yeah, I'm happy to be here. So I guess I will start by sharing my screen. Oh, I guess I can do this. Okay. It starts on the right screen. That's amazing. Okay. So, hello, everybody. Good evening, good afternoon, good night, wherever you are. I'm excited to be here joining you today. So today we are talking about what the fuzz, fuzz testing, an introduction, a nice, light and easy introduction to fuzz testing. I am Josh Grant, and I'll be your speaker today. So hello, I'm Josh. So a little bit about me. I have been working in test automation, doing all sorts of things for over a decade now, since 2010. I've worked with Selenium, sort of end-to-end testing at the browser level and browser testing with things like Java and that kind of stuff. I've also built API test frameworks with Python, which is really fun. And I've worked with customers, I've worked with developers, I've done a lot. And here's some places I worked. Here's a photo of me that is a lizard on my head. This was taken in Cuba on a nice little family vacation. That was good. And a little picture of Toronto. So I am coming to you from lovely Toronto, Ontario, Canada. This is a street scene of Queen West. It's a great place. I recommend visiting it if you're in town. So yeah, that's a little bit about me. So thank you, Sauce Labs, for sponsoring this as a former employee of that establishment. So that's a little bit about me. Fuzz testing. So I'm kind of going down the test automation pyramid, if you're into that sort of thing. And I'm thinking about, and so fuzz testing is kind of on the same level of unit testing, like testing things like an individual function, individual method, or even like a bunch of code working together in some way. So today's talk, I'm going to walk through fuzz testing. What is it? How does it work, or roughly how does it work, and how to use it for fun and for profit. It's a wonderful technique. It's a really good technique if you are a tester, if you are a developer. It's one of those unreasonably effective type solutions. So I will kind of give you some insight on how to use it and what to do with it. So what is fuzzing? I love this. This is a true story. This is 100% happened. So it all started on a dark and stormy night in Wisconsin, at the University of Wisconsin in, I can't remember which city it was, but it was a dark and stormy night. And on this night, it was dark and stormy, it was raining hard, and there was lightning and thunder. So Professor Barton Miller is a computer science professor at the University of Wisconsin. And he was in the late 80s, I think 1989, he was working from home. He was a trendsetter. He was working from his home office at his house, and he was connected through like a dial-up modem to the on-site network at the university. So he was connected. He would do this in the evening sometimes. He would log in, just do email stuff. He was a computer science professor. He was probably doing scientific research, but he connected to the university network from home through like a dial-up modem, probably through a phone line, like this kind of thing. So one night it rained, and it was a stormy night. It was a stormy night. It was electrical. There were some electrical storms. And he noticed something. When he was working this night, he noticed that every time there was a lot of thunder and lightning, or when the storm got worse, he would have trouble connecting to the network. He would have trouble either sending or receiving data, or his network would drop, or like his software would kind of behave strangely. Something strange was happening, only because of this storm. So being a computer science professor, he did a little digging. He tried to figure out, like, is it like my electricity is turning off, or is my power getting shut down? Is something happening at the university? Is something happening at my house? And he did some investigation, and it turns out, so Professor Miller, sorry, I just have to do this. So his network would cut out between his home and his university department's network. And he, after some digging, he found out this was because of the static electricity in the storm, and it was affecting software on both ends of his network connection, or I think primarily it was on the university end. And so this static electricity, or fuzziness in the network connection was causing problems in the software. So the software was actually unable to handle certain inputs. Like, very roughly speaking, it was the software on the network side was unable to handle certain inputs that were fuzzy or staticky, or kind of had some randomness in there. So he found this really interesting, because I think it's interesting, because he found that, like, you can have storm affect software. It's not just, it's not just he was sending buggy data or something like this. It was actually like data being affected by the storm around him. So, he got really interested in this. Being a computer science professor, he was interested in sort of how software works, sort of at a fundamental level. And so he started researching this, and he had his grad students try to replicate some of this fuzzy behavior by writing things that he called fuzzers. And part of the reason he called them fuzzers was that the data looked kind of fuzzy. There was a lot of punctuation, a lot of kind of just strings of different characters. It looked kind of fuzzy. And the goal was to try to replicate some of this behavior. Like, can you crash an application? Can you affect an application's functionality just with these sort of fuzzy strings? And so that's, how fuzzing was born. So that's kind of where the word fuzzing comes from. And that's kind of where fuzzing comes from, is trying to investigate, if you pass in fuzzy inputs into a system, or into a function, or something like this piece of software, how can you affect this behavior? So what is fuzzing? So now we have a reasonable definition. So fuzzing is an automated testing technique where kind of semi-valid, semi-random, or fuzzy inputs are generated and passed into a piece of software to find bugs, or to find security vulnerabilities, basically to explore the application. You can kind of think of fuzzing as an exploratory technique. You don't know what you're going to find, but you're going to pass in these fuzzy inputs to explore and try to find different bugs or different security vulnerabilities. Nowadays, fuzzing is often, but not always, associated with security testing, finding things like different software security vulnerabilities. I'll talk about that later. But really, you can use it to find bugs, functional bugs, this sort of thing. So here's an example of a fuzzy string. So as you can see, like, it looks kind of fuzzy. I think the original strings had a lot of asterisks and decimals and things like this. But you'll kind of notice that you can see that this string kind of looks random, but it's also fuzzy in the sense you have like an open bracket. Well, that caused problems. Is your program always expecting a closed bracket? You have different punctuation. Can you handle special characters? This kind of thing. I wasn't able to do this, but you can also fuzz other types of things. So another popular fuzzing technique is to take an image file or an image format, something like a JPEG, and fuzz it. So kind of manipulate some of its bits or something like this, and create a fuzzy JPEG that you might pass into a piece of software that has to process an image. Like, maybe you take a picture on your phone and it scans it for something. But like, there's different, you can kind of think of inputs in different ways, but they're fuzzy. They're kind of a little bit random. There's a little bit of weirdness in there. So that's kind of an example of a fuzzy input. But the goal of a fuzzer is to generate these things randomly. So instead of a human being sitting around and thinking like, oh, I'll try this input, I'll try that input, fuzzers will generate this for you. They'll kind of somehow come up with fuzzy inputs to try, and they'll try them hundreds or thousands of times. So just like I said, so a fuzzer is a tool that generates fuzzy data automatically and can generate fuzzy tests as well, and passes that into a system under test. So if you have a function under test, if you have you can fuzz entire applications, but you want to pass that into your system under test. And sort of historically, so a fuzz target is a function that gets called by the fuzzer. You can kind of think of a fuzz target as a test case. So now when you think of automated testing, things like JUnit, you might think of like a test method or a test case, however you want to think about that. And a fuzz target is basically a test case that you've written specifically for fuzzing. But people use fuzz target. It's a phrase that comes up a lot. So I'll mention it here. So how does fuzzing work? Right, it's got to be easy, right? You're just generating random strings and things, right? No. So how does fuzzing work? So fuzzers fuzz things. That's what they do. The simplest fuzzers just generate random inputs based on specifications. So give me a random string of length 10. Give me a random byte. Give me like a random string of bytes or an array of bytes. Give me a random or a JPEG that's been fuzzed randomly, this kind of thing. So the simplest fuzzers just generate things randomly or semi-randomly, I guess, and then call a piece of software with that randomly generated input and call it several times. So not just once or twice, but like hundreds or even thousands of times. And they just power through. So it's kind of brute force or kind of like parameterized testing a little bit. So let's see an example. So everyone loves examples. So I'm going to show a basic example of fuzzing using hypothesis. So hypothesis is a component testing tool or library in Python, but it can also do some basic fuzzing, especially when you talk about fuzzing like this, where it's just generating random inputs. It's not doing anything too sophisticated. So, and I'm going to test an encoding function. And I'll kind of show what's going on there. So here's my Python code, and I'll show this. Hopefully, test JSON. So here's the situation. So let's say you have a JSON encoder. So JSON is like kind of output from like an API or like an HTTP call or something like this. And JSON has to have a certain format, has to kind of be like a ordered pair of strings or other data things. You can find examples all over the place. And so in Python, there's a library called JSON, and JSON has two functions called dumps and loads. Loads takes a string and tries to convert it into a JSON blob. And then dumps takes a JSON blob that's properly formatted or something properly formatted or close to properly formatted and tries to turn it into a string. So in this test, and I think this was taken right from the hypothesis examples-ish. So this test basically says, okay, if I take a string and I convert it to JSON and then convert it back to a string, I should get the same thing. So if I call loads and dumps, they're kind of like inverses of each other. So I should get back the same output. So this should equal S. But there could be edge cases. So that's where fuzzing comes in. So here I'm using hypothesis. I import some stuff from hypothesis. And I'm just saying, okay, pass in this string S, and S is text. So it's kind of text values, alphanumeric, maybe some punctuation, and try to find either cases where this function crashes or this function throws an exception or does something funny. It does something strange, and I can do that. So very simple, like all I'm doing is calling this function or calling loads and calling dumps. This is a really, really good example of a fuzz target or like a fuzz test case. All you're doing is calling functions. That's the first step. It's just call the function. It's very easy. So I'll run this. I'm going to run it using PyTest. And it runs and executes. Oh, and look, the test failed. and it found an example that it has buggy behavior. So, and that's the empty string. So in this case, if you try to call, I think it's, what did I do? You try to call load S on empty string, it'll crash. The JSON library doesn't know what to do with this. Fun fact, empty, like an empty response is valid JSON. So I learned this in one of my previous jobs. It's wild. You can have an empty JSON blob, like just like an empty set of brackets. You can have an empty string is valid. Also, nothing is valid. You can also have like this, which is nothing. So fun test case. And it finds it really quickly, finds it efficiently. So fuzzing works. Hypothesis does the job. So that's a really simple example of just how you can randomly kind of go through data and use fuzzing to generate those random cases automatically. So that's pretty cool. So yeah, that's the example of the hypothesis. It's a cool library. Check it out if you like Python, like I do. All right, so going right along, I should have mentioned there will be C++ in this this presentation, so bear with me. I know, again, I know it's inescapable in this line of business. I'll be nice though. It'll be nice. So and the reason C++ comes up is that one of the main areas of interest of fuzzing is C++ programming. So if you have any familiarity with C++, you'll know that C++ provides direct memory access through code, right? So you can say things like with C++, you can do things like set this memory address in RAM to 0, or like block off these 8 addresses in memory. Like you can get very close to the metal. That's kind of phrase. So, and because of this, because C++ allows you to do this relatively freely, also you don't have to free up memory. So you can say assign memory to this block of RAM, and that's it. Like don't free it, don't handle it, just do this. Because C++ is so low level in this sense, it's often used for areas of programming like embedded programming for machines. So if you go to a factory and there's a factory and it has a robot and the robot puts handles on doors, or a really fun example, if you go to an industrial farm, there are machines that will like milk cows or brush cows. I learned this, like automated cow brushes. So those have software in them to kind of control the mechanics of the actual arms of the actual robot. So a lot of times these are written in C or C++. So that's embedded programming. It's kind of cool. It's kind of different. So, and when you talk about embedded software, so there's, in addition to other areas, 2 really critical aspects are security and safety. So security asks questions like, can someone hack into this piece of software and then control a robot, or make it crash and then turn the robot off, or this kind of thing? That's one important question about security. But then there's also safety. So suppose the software in your robot arm crashes, does your robot like gracefully stop working, or will it like drop something, hurt someone, this kind of thing? So these are 2 really, as you can imagine, these are really important areas of testing. And fuzzing is really effective at finding issues related to this, right? C++ is infamous for having memory leaks, resource leaks. You might allocate certain, or you might allocate or not allocate memory properly, and it causes issues. So, so a lot of fuzzers have been developed specifically in the C++ world for issues like this. So, and I'm going to show an example. So, one of the most common fuzzers, or one of the most like well-developed fuzzers, is libfuzz. It's called libfuzz, and this is going to find a memory leak in C++. So let's take a look over here. Let's go here. Okay. So let's go and take a look at this tutorial fuzzer. Okay. So here's a bit of C++ code. And in particular, there is this function called fuzzme, very novel, And fuzzme takes a pointer. I'll kind of brush over this because it's no one cares about this. So basically, it takes two arguments. It takes basically a list or an array of integers called data. So let's say you have a list of, well, strictly speaking, an array of integer values. Maybe they represent like heights or temperatures or something. And then data size. So like how many? So you have some data, and then you have like a size of that list or that array of data. And then it does this thing. So it does this kind of stuff. Data size is greater than or equal to 3. Assign these values. You can assign F, U, Z, Z. C++ world, you can think of characters as integers. Again, we're kind of low-level programming type stuff. But there's a very subtle bug. There's a very subtle memory leak in this. It took me a couple times to see it, actually, because I'm not really a C++ person. And it's this, is that in the case where you set your data size to 3, exactly 3, so you could have 1, 2, 3, 4, 5, up to whatever. If you set it to 3, then this data element is not well defined, because you have 1, 2, 3, 4 elements. So if you set it to 3, something weird happens. You're basically trying to set a value to something that you haven't defined properly. So you have a list of 3 items, you try to add a 4th item. C++ doesn't handle that gracefully. Also, I can tell you that these type of bugs or memory leaks are very common. It's very easy to make a mistake like this. This is a really nice example. It kind of, you can see it pretty clearly, like, oh, like what happens if you set it to 3? Oh, this looks like a problem. And there's even this like little unhappy face to kind of suggest something is up. But believe me, in the real world, like these bugs can be very difficult to find. So that's the kind of function under test. But then we also have this fuzz target. This is written using the libfuzzer kind of syntax. So it's saying, okay, write a function called this, extern C. I don't know what that does. But basically call fuzzme. So call fuzzme with this data. The fuzzer will randomly generate data for data and for size. So it'll give you like a list or a pointer to an array of integer data, and then also size. So it'll fuzz those two things and then return it the function. So the way this works is that so C is a compile, or C++ is a compiled language. So you do a compilation step, and then you actually run your executable. And so when you're fuzzing this, let's see. Sorry, I lost my command. Everything's going so well. Okay. So when you can compile, you can call the Clang compiler, clang compiler. It'll compile into an executable, and then you can execute it on your platform. But you can also add additional options. So one option is to fuzz it. So you can build an executable that uses the fuzzer, and that when you call your default executable, it'll run through all those generated fuzz values. So it's something like, let's see, I'm going to have to go to so what I'm going to do, there's a command. So Clang is the compiler, so that's how you compile it. If I go to tutorial, grep fuzzer tutorial, and this so this code base is actually from Google. You can find it if you search for Google Fuzzing or Google Fuzzing libfuzzer, you'll find this exact project. It's supported by Google. A lot of large software companies invest in fuzzing for security purposes. So Google, Facebook, Microsoft, those type of firms are very serious about fuzzing. And so they provide resources like this. So we're doing that. Aha, here it is. So I have to do this. Thank you for bearing with me. So copy. All right, so I'm going to put this. Oh, actually, cancel out of that. Okay. So what this does, if you are familiar with, or even if you're not familiar with C++, so Clang++ is a C++ compiler, and you can pass in some various arguments that do lots of different things. But in this case, we want to call this fsanitize fuzzer. So fsanitize fuzzer calls libfuzz and builds an executable that will run through all these different values. It'll generate all these different values in a very smart way and try to find interesting outputs. So if I run this, oh, right, let's go up. Oh, and oh, right, okay, Fuzzing tutorial. Okay, so now it builds this file called aout. And if I run this, I get all this stuff. So this will actually, this runs the libfuzzer and provides output. And it's able to find, and again, this is all low level stuff. If you're a C++ programmer, you know what this means. I don't. But it will find, I'm trying to think of where the failure is. It does find that there is something wrong. There is a heap buffer overflow given some input. And that finds that issue of if you pass in a value of 3, you'll get some undefined behavior. I think there's a better. So yeah, so there's that. So that is libfuzz. So libfuzz in C++. If you're doing C++ work, definitely look into fuzzers 100%. So yeah, so that's that C++. So let's keep going. So how does fuzzing work? So we've talked about random fuzzing and just generating random values. And computers are pretty good. They're pretty good at generating loops and automation. That's what computers can do. They can repeat the same action a lot of times. They're perfectly happy to do that. So we can leverage this and we can go beyond simple fuzzing, right? Like there's different techniques that have a long history since 1989. Mutational fuzzers are fuzzers that start with a known case, like a seed, and then mutate. So you can mutate every kind of value in a string or mutate every bit in a string or something like this. And generational fuzzers start from scratch every time. So there's two different ways to think of approaching fuzzing. So one is like, let's mutate data and keep mutating like one thing at a time until we find like a buggy situation or something. Or another thing is like, let's just generate new data every time. Let's just like start from scratch and generate new things every time. Both are effective and both can do the job. But people are pretty good with computers. Like people are pretty smart. And so smart people, very smart people, have developed coverage guided fuzzing. So this goes beyond just randomly generating data. This approach uses instrumentation in the software, in the fuzzer, to guide the fuzzer to interesting results. So this is using things like different evolutionary algorithms to kind of feedback and look at what the output of the previous run was and sort of analyze that and kind of drive the fuzzer towards something interesting. This is a case of using artificial intelligence, not the LLM style that's popular right now with chat GPT and all that stuff, more of a classic case of AI. So, and most of the widely used fuzzers today, like libfuzz or AFL or other ones, use coverage guided or feedback based approaches where there is this sort of gray box flavor of, let's look at the output of the last test case and use that as input into the previous test case or into the next test case. And these, like I mentioned, these use evolutionary algorithms to guide the fuzzer. These are a lot more efficient. They work a lot faster, and you can find, bugs or security vulnerabilities a lot more efficiently using these approaches. And I'll underline again, very smart people have worked on these, so they work. So here's my favorite example. So kind of in the last two examples, we found sort of low level bugs. So including like what happens when you have an empty string, like if you tried that case, or finding like an integer value, like kind of running through integer values. Let's do something a little more sophisticated. Let's find, using a fuzzer, a SQL injection vulnerability. So let's take a look at this. I got to skip over to here. So I'll kind of walk through the beginning. So here's, let's say I have a Java application. I'm in Java world now. Everyone's a little happier about that. So let's say I have my Java application, and this application connects to a database, a SQL database. And I want to pass data into my SQL database. I want to just pass in data. In this case, this is an application called Road Smart, is a buggy test application based on road data. So let's say you want to know the name of a road or what the speed limit is. This is an application that will help you with that. It's also full of bugs. So let's say, so this is a method that's present in that piece of software. So, and it's called insert road data. So you have this road object. The road object has things like a road name, a speed limit, what country it goes through, that kind of thing. And you want to pass in this data into a SQL database. So you kind of, process your data, get your road data into kind of a good way, so you can pass it into your database. And then you do exactly this. So I've written code like this. A lot of people have written code like this before. So you put everything into strings. So you convert all your data into strings, and then you call an insert statement, and you say, okay, insert into roads, my table called roads, this value. So I have like a new road I want to insert into my table, and I'm just going to call like a SQL query to do this. So kind of at a high level, you connect to a database, and then you have a query that you can say, insert my data into this database this way. And you go ahead and do that. So you pass in, so I have my road name, country, length, speed limit, and I just create a query and execute that query, and then it updates the database. So pretty straightforward. This looks fine, right? This looks like no problem, except there is a problem. There's a large problem. This has a major security flaw. And the major security flaw is that these are all just strings. So I can pass in a malicious string value, because again, like my road, get name, get country, length, speed, these are all strings. So it's possible to pass in something malicious. So I could pass in a string that will unintentionally delete all the data in my database, drop tables. If you've seen the XKCD comic, Little Bobby Tables, that's like a really funny example of, just being able to drop tables and delete data. I could, insert data in a malicious way. I could say, well, I'm just going to rename every single road, Highway 401. I'm just going to, ruin the data or something like this. So this is an example of SQL injection. So this is still a really big security issue. Still very common out in the world. And it's the reason why you shouldn't just pass in unsanitized input. So don't just allow users to just pass in any old string, because maybe they'll pass in a string that does something very bad. So, but on the other hand, this is code that's very easy to write. I've written code like this. A lot of people have written code like this. It happens. But there is a SQL issue. And the other thing is that code like this, kind of like the C++ example, is it can be hard to see, right? It can be hard to see. You might be looking at this thinking like, I don't see a problem. I don't, like, you're connecting to the database. Like it's difficult to kind of just find these kind of bugs. Security vulnerabilities can be really tricky to find, just overall. So what I'm gonna, not that one. So in this case, I can test this. So I have some tests here for this. Same thing. So I want to test this insert road data function. I'm going to write a unit test, or method, I guess I should say. So this insert road data method. And so I can do that using JUnit, everybody's favorite. So for example, here's a unit test. So here's a unit test. I initialize my database. I create a test road, like this road object, this test fixture that I want to use in my tests. And then I call the function, and then I verify, like, did I get the result, right? And I can call this, and it kind of works. So the basic functionality works, but I might not catch the security issue. Like I might not think of, what if I call this with something malicious? Like what if I tried like drop tables or something like this, right? I might not think of that. I might not even know what this means, right? Like I barely know what this means. I'm not really a database expert. So, or there could be other weird data, like what if you put in like, USA and like that does something strange because there's some weird rule or something, right? So, so along with this, I've written a fuzz test. So this is using Jazzer. So Jazzer is a fuzzer that integrates with JUnit, provided by Code Intelligence. It's a really good one. And so I'm using this library. You can get it through Maven. It's kind of standard library. And it basically leverages JUnit to say, okay, let's write a fuzz test. So now instead of fixed value, I'm going to pass in this data. And this is the fuzzed data. So this fuzz data provider is what the fuzzer is going to use to generate all those values. And it's going to call this test method a whole bunch of times, trying to find some kind of bug. So let's run this. Unfortunately, I would love to click this button and have it run, but that's not the way it works. So instead, let's go back here. So I'm going to use CI Fuzz. CI Fuzz calls Jazzer under the hood. CI Fuzz is kind of a multi-platform fuzzer. You can fuzz it with Java, Kotlin, and C++. It's really cool. Definitely check it out. So I'm going to call CI Fuzz run and information. I want to call this method base or this class. So I want to call this copy, and I'm going to paste this in here. And so CI Fuzz knows, okay, look for this fuzz test and then execute it and generate inputs based on this thing, based on selecting the random strings. So I call this, it does a whole lot of stuff. It's trying different values, it's generating different things, and boom, lo and behold, like it's very quickly, it finds that there's a security issue. It finds that there's a SQL injection in this code, which is really, really cool. I was amazed by this, that like a fuzzer cannot just find something like, if you change this byte to this value, you get a bug. Modern fuzzers can do things like finding SQL injections or finding other injection attacks, like if you pass in a malicious string as a command or something. So it's pretty cool. It's pretty sophisticated. And it did it pretty quickly, like just in a few minutes or like a few seconds even. So that's pretty amazing. And of course, like there's all this data you can take a look at, Code Intelligence, it's fine. You can take a look if you or not, it's fine too. But yeah, it was able to find, based on this fuzz test, it was able to find the SQL injection. So that's pretty cool. That is pretty neat. And yeah, I really like that example. All right, so how to use fuzzing. So I've given some examples. Let's think about how you might use the fuzzer. I definitely recommend, if you are a tester, if you are a security engineer, if you're a developer, if you're just a person who likes messing around with software, definitely take a look. There's a lot of different fuzzers out there. They handle different situations, different cases. So like one way to use fuzzing is bug detection. Let's say you're trying to find unusual edge cases. You might be a clever tester and you're able to find different edge case values or different inputs, but a fuzzer might find even more stuff that you didn't even think of. So that's one thing. Memory management or mismanagement. Fuzzing is really good at finding things like stack overflows, buffer overflows, like not like in the kind of the C++ world, like things like not freeing up your memory or not allocating memory properly. It's really good at that. And in the Java world, sometimes you can find null pointer issues. So sometimes you'll have a bug and your code doesn't compile because it's throwing a null pointer and you can't find it and it's crazy and you're trying to think about how to do this. Sometimes fuzzers can find that pretty quickly. So that's cool. That's one kind of way to think of a fuzzer, is like, I'm going to use this to explore and find some bugs, functional bugs. Another way to use fuzzing is to find security vulnerabilities. So if you put on your security hat and think like, I want to evaluate, is my software secure? Does it have any security issues? In some cases, for example, if you are in Germany and you are if you are developing software for embedded software and for robotics or for automotive, there are ISO standards where you must do certain things to ensure safety or ensure security. So you can find security vulnerabilities, things like injection attacks, like SQL injection attacks. Again, memory mismanagement. Sometimes this is considered a security issue. A hacker can pass in malicious data, right, and do certain things to prevent, to find hacks into a program, or to access data, or to do something malicious. And also program crashes. So sometimes programs crashes are a security issue. If you have a crash, like that could cause like a cascading failure or something like that. So fuzzing can be used to find these sorts of things. So kind of to wrap up, going to the end. So some high profile exploits. So fuzzing is really cool, but there's been some really big things that have been found through fuzzing. So one of the biggest, probably the biggest, was Heartbleed. You may have heard of this. It was from 2016. So Heartbleed was a very high profile security exploit in the OpenSSL library. So basically, if you're using anything with HTTPS, the S stands for security, OpenSSL is handling that. So there was a bug in the OpenSSL library which was exploited, and you could basically use to send malicious stuff via HTTPS. It's pretty bad. It even has the logo, like this is the Heartbleed logo. And you can find it, and it was found using fuzzing. So I believe using libfuzzer, the security engineers were able to find this bug and kind of show that it's important. It got fixed in short order because, again, it was very severe. And then log4j. You probably heard of log4j or log4shell. So this is from 2021. So this was a very big, a very large security vulnerability in the log4j library, which is a logger library. If you've worked with a Java project, you've probably worked with log4j. It's one of those dependencies that just appears and is around. And it's a logger. It just spits out like information or error or something like this. But there was a very high profile exploit where you could access a system remotely through log4j. This was the only logo I could find for it. I did not come up with this logo. Very, very high profile exploit. There's like a ton of stuff online about this. People are still talking about this 2 years later. But you can also find this using fuzzing. So that's pretty cool. So in conclusion, so thank you for joining me this far. So fuzzing is cool. It's a cool thing. It's been around. It's not new. People have been working on fuzzing for a long time. It's very cool. And you can use it to find either security issues or just bugs. Like you just might want a new approach to find bugs in your software. So here are some links to kind of the tools that I showed off. So Hypothesis, a Python library, check it out. LLVM is the compiler project that Clang is found, and libfuzz kind of lives there in that Clang world. And then last but certainly least, code intelligence testing. You can find CI Fuzz. It's a free download. I definitely encourage you to try it out. That's what the QR code is for. So if you scan your QR code with your phone, you can download it from GitHub onto your phone. I don't know what I was thinking. But yeah, definitely check that out. And thank you. That's the end. So yeah, thanks a lot.
Yeah, thank you, Josh. Fascinating stuff. You probably mentioned two of the bugs that, I don't know, went through mainstream media, right? So they were like really, really high profile.
Yeah.
I'm sure my parents wouldn't remember, but I'm sure they heard of this. Yeah. So this is actually this, right? This affected people in the real world. Yeah. Also, yeah, nobody's going to scan that right after you talk about security issues and then you give us this QR code. That's not happening. But yeah, thanks for the links anyway. So yeah, so if anyone has any questions, feel free to ask in the chat or unmute yourself. I will start off by asking, this is probably not the first test you write in a new project. So at what point or what level of maturity would you say this becomes interesting?
Yeah, this is a great question. Yeah, this is a really good question. Yeah, I agree completely. You're probably not going to start with fuzzing. One, because, well, mainly because fuzzing can't tell you anything about functionality, right? It can't tell you, is my software working the way it's supposed to, or like, is this feature working the way it's supposed to? It can only kind of tell you, here's an error, or here's a crash, like this kind of thing. So when should you use fuzzing? So a great question. So one, if you have to, if you're working in a regulated industry where there's requirements for security or for fuzzing, you have to. So definitely take a look at what's available and what kind of fuzzers are around. And I guess the other way, or the other suggestion I could make is if you have any kind of security or security related issues. So if you have an application that has end users, maybe an application people are paying for, there's support related items there, definitely consider using fuzzing to find those security issues as well. So yeah, it's a really good question. It's definitely not the first thing you should reach for, but eventually it's a good idea.
Yeah, thank you very much. Any other questions?
I have one. Do you have some favorite programming language where you think fuzzy testing is better? And at the opposite, do you have some languages that you think they are frameworks that are not well adapted to fuzzy testing?
Yeah, well, this is another good question. That's good. Favorites. So I'm not like an in-depth expert. Like there are people for whom like fuzzing is a whole research area, and they probably are really good people to ask. So I like fuzzing Java is really interesting because so I'll kind of say Java is a good, or it could be something interesting to fuzz because so Java as a programming language has a lot of nice features that C++ doesn't have. So like memory is managed for you, and you don't have to allocate memory, and it's not low level like a lot of those, which is a big problem with C++, because that's where you run into these issues of memory leaks and crashes and nasty things. And so Java already has some advantages over lower level programming, but you can still have issues such as like a null value or like a SQL injection, like something like higher level security. So fuzzing Java or Kotlin, I guess, if you're on the JVM, that's really interesting to me. Like that's pretty cool, because you might find some like really big deal issues, I guess, for lack of a better word. Least favorite. Well, I mean, least favorite. It's a safe space. I'm not a big C++ fan. I just don't like C++ just in general. It's just my personal bias. It has its place. Everything's good. Fuzzing is definitely really integral to C++, but it can be, the tooling can be not user friendly. So I guess that's my answer. Yeah.
Thank you.
Thank you very much. We have another question from Renata. You want to unmute yourself and ask, or should I read? Okay, I will read. So Josh, in your experience, at what pipeline stage would you have this? So, and would you run with every merge request?
Ooh, yeah, I love this question. So would I run with every merge request? So the answer I'd give is it depends. I love this answer. So fuzzing is exploratory, right? You don't know what you're going to find. You could find a really severe bug very quickly. You could find nothing after running a fuzzer for hours. So when you think of it in a pipeline, this definitely came up in the past. When you think about running fuzzers in a pipeline, you can almost think of it as like doing exploratory testing in a pipeline. So one approach is to say we're going to run a fuzzer for a fixed period of time and then just analyze the results. So just run it for an hour, run it for a minute, run it for 24 hours, however long you can do or you feel. And then just look at the results and almost in parallel. So like for example, with unit testing, you might run a set of unit tests, and if it finds a bug, fails the pipeline, you have to go back and fix it. Fuzzing you might say, okay, we're just going to run it for an hour and see what happens. Maybe you run it every night against the system. Unless you absolutely have to, I don't think I would recommend running against every merge request. You might have to in some industries, but I don't think I would recommend that. Think of it as more of like an exploratory, run it for a fixed period of time, see what happens kind of thing. But it's a really good question. It's a really, really good question. Yeah.
All right. Thank you. Any more questions? Okay. Then I think we're going to wrap it up. I will take over the screen sharing. Let's see. All right. See my screen? Okay, nice. Very good. Full screen. Yeah. So yeah, thank you, Josh. Good stuff. We have a couple of upcoming events. So the next one is next week, actually, already. And it is a hybrid event. So we have a physical event here in Berlin. So if you can make that, I would love to meet you guys. Yeah? If not, you can join us online, of course. We have two talks. The first one is zero-line test suite, write expressive test suits that will age well without programming knowledge. Probably not the same audience that is writing fuzzing tests, but yeah. And the second one is E-Rezept. Sorry, I have to pronounce this German. Yeah, E-Rezept test suite, end-to-end testing of the German EASE prescription. So if you have the time, feel free to join. If not, check out continuoustestingmeetup.com. And then we also have, I think, in another, what is it, another 2 weeks or something like that? Yeah. We have another talk about contract testing and API testing for microservices on the foundation of Cypress end-to-end tests. So if that's something you're interested in, feel free to sign up. Thanks, everyone. Have a great evening. Goodbye.